Hello students, your teacher here, Mr. Sarasinski, with another episode of Algebra 1. Here we are solving factored form of a polynomial, and this is like our first lesson as we enter into factoring, and so it's pretty exciting and pretty important. And so I thought it would be useful as we begin to solve polynomials first to just look at the different forms of a polynomial because there are three. The first is non-standard form, and this would be an example like we saw in our notes where we had to actually rearrange it. And so here you can see this isn't in standard form because everything is not on one side of the equation, first of all. And so we would need to move that 2 over before it could be in standard form. Now, standard form would be x squared minus 3x plus 2 equals 0. And then factored form would be x minus 2 times x minus 1. And this last form, factored form, is what we're looking at today, and I'm going to teach you how to solve this. Okay. You can see that here. Those two parentheses are being multiplied by each other. A polynomial is in factored form when it is written as a product of factors. And so here I have some examples that are in standard form, and then I'm going to show you what they look like in factored form. And I'm going to teach you how to write polynomials in factored form, or factor them, I should say. But right now, I just want you focused on, what is changing, what does it look like, recognition, so that if you see factored form, you know what to do with it. Okay. And then x squared plus 5x minus 24 in factored form. This would be x plus 8 times x minus 3. Okay. To solve a polynomial in factored form, we use the zero product property. And when we solve a polynomial in factored form, it gives us the x-intercepts of the graph. I just realized I had a little typo here. Solve polynomial in factored form, we use the zero product property. And find its x-intercepts. There we go. These x-intercepts, also known as roots, solutions, and zeros, all of which you do need to know. All right, so, and here is the zero product property, just so you know what the property actually says. It says if the product of two real numbers is 0, then obviously one of the factors has to be 0. And this is what enables us to set, in a moment you'll see, set each factor equal to 0 and solve for x. Okay. So now, example 1, we have x times x plus 8 equals 0. So using the zero product property, we're going to set each one of these factors equal to 0 because we know one of them has to be 0. So the first one, actually I'm just going to draw a dotted line here. And this is just separating my two factors. We have a factor of x and a factor of x plus 8. And I'm going to set each one equal to 0. So x equals 0 and x plus 8 equals 0. Okay. And my next step, I am going to use the zero product property and solve. So let's see. This one is already solved, right? 1x equals 0. Well, if you divide by 1, x is just 0. And then over here, subtract 8. X equals negative 8. So my second step was to use the zero product property And then my last step was to solve for x. Okay. And my answers are in set notation, -8 and 0. So the roots of this quadratic are 0 and -8. That means if we were to graph this quadratic, that is where it would cross the x-axis. Okay, next example. Actually, recap. All right, so it's already in factored form. So we write the equation, we use the zero product property and set them equal to 0, and then we solve for x. Usually just two steps maximum. It's a number of steps to solve. Okay. Example 2. All right, we have x plus 6 times x minus 5. Okay, so again, we've written the equation. Now we're going to use the zero product property. I'm going to go ZPP. Zero product property. Okay, and we're going to set each factor equal to 0. So x plus 6 equals 0 and x minus 5 equals 0. Okay. And then the last step, we're going to solve each equation for x. So subtract 6, and these are just one-step equations. X equals -6, add 5, x equals 5. And so in solution set notation, it would be -6, +5. And so the roots of this quadratic are 5 and -6. So those are the places, if we were to graph this, where it would cross the x-axis. And our last example, we have 3x times x minus 4 times 2x plus 6. Okay, so I've written the equation. Now I'm going to use the zero product property and set each factor equal to 0. Okay, so I have 3x equals 0, x minus 4 equals 0, and 2x plus 6 equals 0. And now let's solve for x. Okay, so divide by 3. X equals 0. And if you have a factor in front of the parentheses like this that contains a variable, one of your solutions or roots is always going to be 0. All right, so then add 4. X equals 4. Subtract 6. Divide by 2. -3. So the roots are actually first, if we do set notation, it would be -3, 0, and 4. So the roots are 4, 0, and -3. So those are the places where this graph, this cubic graph, crosses the x-axis. I am your teacher. This is the way.